The Connect Wallet button is one of the most important aspects of your Web3 applications. Every action that your users take that requires them to update some state or write some information to the blockchain is first going to require them to connect their wallet to your application. When I first started building in Web3, I only really knew of one option, which was MetaMask, which is a popular browser extension for crypto wallets. What I was doing was I was asking users to install the browser extension, load up their wallets with crypto so they could pay for the gas fees, or even add the network that I was using into their MetaMask wallet because I was using a different network other than Ethereum at that time. And this just required a massive steep learning curve for new users in the Web3 space to understand crypto, understand wallets, understand gas fees, and understand accounts that they needed to write down, the secret password on a piece of paper and save it in their bedroom, which is just crazy. And something that I've taken notice of, a lot of companies are kind of following this trend of abstracting away the need to even have a wallet at all. And in this video, I'm going to kind of demonstrate all of the different options that I'm aware of to allow users to connect their wallets to your application. And I'm going to put these on a scale of how secure they are compared to how easy to use and onboard new users they are into the application. So I'm going to jump into a quick diagram and then I'll show you some code and some demonstrations of each of these options. So let's jump into Excalibur here, and I'm just first going to draw these two kind of axes. I don't know how to say that word. Two lines here. One is going to be how easy it is to use. So we're going to say ease of use, and then down the bottom here, we're going to say how secure we think this is. So it's going to be a kind of balance of how easy to use the wallet is. So how easy is a new user onboarded into the Web3 space compared to how secure that wallet is that they're connecting to your application in the long term. So I've just scaled it up a little bit and added some labels just so it's easier to understand. Basically down the bottom left, it will be easy to use, weak level of security. Up the top right, it will be hard to use, but stronger and more secure in the long term. And the first one I wanted to talk about was something that I think we're seeing more and more frequently in the space is users don't necessarily always care about the aspects that Web3 enables, right? They want to use the application or they want to play the game, but they don't necessarily care about taking the in-game assets or the digital collectibles or the NFTs, or whatever it is that your application is using the blockchain for outside of the context of that application, right? They just want to use your app or play the game. The blockchain is kind of irrelevant to them until they might want to, at a later time, want to opt into this kind of behavior that the blockchain enables in your specific use case. What I think a great example of this is actually just creating a wallet for the user under the hood. So down the very bottom left here, where it's extremely easy to use and onboard new users into the Web3 world, but has very weak levels of security, I would say, is a generated wallet. So a generated EOA wallet. A generated EOA wallet just means the application developer or the game developer is creating the wallet for you under the hood. And as a user, you either can be exposed to this and type in a password to say, okay, here is my password that I'm going to use to encrypt the information of this wallet into the storage of the device I'm using. So in the browser, that will be in the local storage. In iOS or Android, that will be on the device storage. Basically, you're either choosing to write the private key essentially directly into the device's storage, or you're adding a layer of kind of encryption to that by saying, hey, sign up to our website. So you type in a password. That password is what's used to encrypt the private key or the signing rights into the device's storage. And whenever you go to use that wallet, you can use the same password to decrypt the value out of the storage and continue to use this wallet under the hood. This is amazing for new users because they don't necessarily care about the wallet, right? They want to use the application, and this is the fastest way for them to onboard into the Web3 world. The wallet gets created for them. They never need to install a browser extension. They don't even need to accept any transactions or pay any gas fees. But this is a weak level of security because as soon as the device storage where the wallet's private key is encrypted or stored it's essentially that wallet is gone. You're not going to be able to recover that, right? And the other risk to this is anyone with access to the private key in the device's storage or access to the password can access and fully control the wallet that got generated for you. You also don't necessarily know what read information the application developer has over that wallet when it gets created for you. So maybe if you're interacting with some sketchy websites, they're creating the wallet for you. Maybe they do have access to the private key. You don't know. They're the ones that generated it for you, right? So this is something where you're kind of trusting the application developer to create the wallet for you, which is why I'm giving it a very low level of security. But you don't need to install a Chrome extension. You don't need to load up your wallet with gas fees. You don't need to interact with any aspect of the Web3 world when you have the application developer generate this wallet for you and use that specifically to interact with their application or their game. So here's the demo that I wanted to show you for each of these wallets that we're going to talk about. Source code will be in the description on GitHub, fully open source, and we're using the ThirWeb React SDK to power all of these Connect wallet options. So here's an example of the local wallet. And in this specific example, we're using that encryption that I talked about where the password the user enters is what's going to be enabling them to encrypt it into local storage in the browser. So I'm typing in the password. That password is required to decrypt that value out of the storage of the device. So every time I click Connect Wallet here, it's going to say, hey, choose a password for this wallet. You'll be able to export this wallet with the same password. So at any time, the user can actually take this out of being a local wallet. It still got generated for them, but they can take this local wallet out of the device's storage and say, okay, I actually do care about what's stored in this wallet. I'm going to export it, and maybe they'll import it into a browser extension wallet like MetaMask or Coinbase wallet. And that way they have a bit more control over what's going on with that wallet and less risk of actually losing the access to that wallet overall. So here's an example. Let's just type in the suggested password from Chrome here. I'll click create new wallet. And what the application is doing is it's just generating this new wallet for me, right? And you can see here is the wallet address that got created. And it has a nice little warning message here to say, this is a temporary guest wallet. Back it up if you don't want to lose access to it. So that's just basically saying, if you actually care about what's in this wallet, hey, you should probably back it up, store the value that you can recover this wallet address with. So if we click this backup button, it's going to download a JSON file containing the wallet information onto your device, encrypted with the password. If we look at the local storage here, so if I go into the application, the local storage, and actually just zoom in and see here is the local wallet data. You can see here is the address that we just saw. It is encrypted. Here's the encryption strategy. There are a couple of different options available for encrypting this into your device storage. And here is kind of that encrypted value that gets read. The cool part about this is when you interact with the smart contracts, you don't even need to accept any transactions because there's nothing to accept. The local wallet doesn't install anything that prompts you to say, hey, here's the transaction, here's the gas fee associated with what you're trying to perform. It actually just has access to accept anything, right? Which again is a pro and a con. The pro being it is much better for new users who don't want to interact with the Web3 aspects. The con being, well, you can essentially just accept any transaction from this application. So again, this is very good for onboarding new users, but in the long term, hey, there's a lot of risks associated with it, but you can say export, back up this wallet, import it into a browser wallet, and maybe transfer the funds or the digital collectibles, the NFTs, out of this generated wallet into a wallet that you have more control over. The next one I want to add to this chart is very similar, and this is going to be a generated wallet. So a generated EOA wallet that acts as a signer for a different kind of generated wallet. So we're going to say acts as a signer for a generated EIP 4337 account abstraction wallet. So that's a mouthful, but this is generating the wallet. So what we just saw was generating an EOA wallet and then under the hood that gets stored in local storage, where you say, okay, this user has decrypted what is stored in local storage by typing in the password that they entered originally. Then we can sign any transactions from that wallet. But one of the risks and one of the downsides to that was the user is trusting us that we haven't stored that information ourselves, right? That we don't control that wallet's private key, or we never saw it, right? Which is a big risk for the user. What if they wanted to change who can access or approve transactions from the wallet that you generated for them? And this is what this next step enables. So we're going to generate first an EOA wallet, which is just a regular account in Ethereum that can sign transactions. So we're going to do that same process. The wallet that we generated for them is going to be able to sign transactions from a smart contract wallet, which is what this EIP 4337 account abstraction means. It's a smart contract that is essentially also a wallet. So we're generating an EOA wallet, which is an individual wallet. That wallet that we generated is going to be able to sign transactions in another smart contract wallet that we also generate for them. The benefit to this is that you can change what signer is able to sign transactions on the smart contract wallet. So let's say you start to figure out what's going on more and more behind the scenes as a user. You say, hey, I actually don't trust this application. When they generated the wallet for me, what if they know my private key? What if they stored this information somehow? I want to change who can control the information in my smart contract account. The smart contract has a function built in to change who can approve transactions in that smart contract wallet. So you could change the approval from being the wallet that got generated for you by the application to being a different wallet that you created and you fully control. And this is something that's kind of a middle step between, okay, I want people to be onboarded into my application, but at a later date, maybe users will start to figure out more and more what's happening in the Web3 world and why owning and controlling your wallet is really important in the kind of long-term level of security here. So I want users to be able to change or kind of opt into this behavior where, hey, you can control your own wallet. You can be the one that creates the wallet who can approve transactions in the smart contract wallet that we created for you. And the owner of the application can't dictate what happens on that account abstraction wallet because it has these standards in place where it's basically just saying, okay, here's a list of signers, which initially is the one that we generate for them. You can change that to your own account at a later date. So it gives you the best of both worlds where you generate it, you generate the wallet, you onboard them into your application, and then the added benefit is you can actually allow the user to become kind of the owner in their own, controlled environment of the account that you generate for them. So if we go back to our demo and we click on the local wallet plus smart wallet tab here, we'll again be able to connect our wallet. This time we'll just enter the password for the local wallet that we just generated. So it's basically saying here, oh, there's already a wallet in the local storage of this browser. So let's just retype the password to decrypt it and be able to interact with smart contracts from that generated wallet. So we'll first connect to the local wallet. And you'll see a quick flash there. It said connecting to smart wallet. So what's happening here is, and I'm going to lie a little bit here just to make it kind of easier to understand, but what's happening here is it's generating or creating a smart contract wallet for us. The reason I'm saying I'm lying is because it's technically not generated or created as a wallet until you initialize the first transaction. So in your head, you can think of, okay, I just signed in with my local wallet and a smart contract wallet got generated for me. So if I were to interact with a smart contract from this current state, transactions would be coming from this smart contract wallet here. So OX4006, which is different from, if you remember, the local wallet, which was OXE046. So it's a different wallet. The way that you think about this is the local wallet is the one that is able to approve transactions for the smart contract wallet. So the smart contract essentially says, where did this transaction come from? Is it from one of my approved signers, which in this case is the local wallet? And if it is, then the smart contract wallet will handle that transaction. If it comes from some random signer or wallet that isn't approved to initialize transactions on the smart contract, then it won't execute those transactions. As I mentioned, the benefit to this is the local wallet currently is the one that has permission to sign transactions on the smart contract wallet. If I was a user, I could again export the local wallet, import it into my browser and have control that way. Or from the wallet that currently has permissions to execute transactions on the smart wallet, I could say, I want to change who the signer is on this smart contract wallet. So from the wallet that got generated for me, I would say, hey, I just created this new wallet. I want to switch over permissions to that wallet. And you are enabled to do that by this smart contract wallet setup here. So that's the benefit from local wallet. The only option you have is really create a new wallet and transfer everything across. Whereas what this enables in this kind of specific setup is instead of creating a new wallet and transferring everything across, you just create a wallet and then you can choose at a later date to say, nah, I want to use the different wallet that I created to be the one who controls this account rather than the one that you generated for me. I do have another video on account abstraction that will be linked in the description if you want to check it out. The next one I want to talk about is non-custodial wallets that also get generated, but this time it's by a kind of third-party service. So this is where you log in with something that's familiar to you in the Web 2 world, such as your phone number, your email, your Google account, your Twitter account, some social login, and a service associates that login with a wallet that they generate for you. So every time you re-log in with that email or you re-log in with that Google account, you're going to be connected to the same wallet that got created for you under the hood by a service such as Magic Link or Paper Wallet. So here's the Magic Link homepage. You can kind of see if I click this Mint NFT button, it's going to ask you just log in with Google or email, or it's pretty much the same thing in Paper Wallet as well. In our application, if we click Connect Wallet here, you can see you can type in your email or your phone number. This will send that email a code, and you type in the code to kind of prove, hey, I actually do own this email or I do have this phone number, and then you will be connected to your to your account that way. So they generate the wallet for you. Your login is associated with that wallet and you're able to reconnect to that same wallet by the same method of login that you used to create it. So this is kind of in the same genre of generated wallets, but let's say non-custodial service generated wallets. So what I mean by this is a service or a third-party company is the one generating it for you. And again, this comes with kind of the same risks where it's, hey, do I trust this third party to do the right thing by me and be able to not recover my private key or not act from the wallet that got generated for me? These companies that I mentioned do have those guarantees to say, hey, we're not able to log into the wallet that we generate for you from our end. We distribute the key in different ways, but again, you're trusting a company, you're trusting the engineers of that company to do the right thing by you and not be able to use your wallet. But this is very easy to use again. I would argue it's more secure than the wallet that gets generated for you, because if you lose the device or if you lose the local storage or if somehow the memory on that device gets wiped, you lose complete control over the wallet. You can never recover that. Whereas with this kind of social login, with the email login, you do run the risk of, oh crap, I lost my email, or I changed phone numbers, or I can't log into that account anymore. Then you won't be able to recover the wallet, but it's arguably more secure because the risk of you losing your local storage compared to losing your main email account is, night and day. It's much less likely for you to lose logins than it is to lose your local storage, for example. So that is why I've said it's more secure. I would say it's kind of similar to this level of ease of use, but the reason I put it higher is because it does kind of require you to say, oh, there's a wallet being generated for me. You don't have the option of completely hiding that from the user. Whereas with this generated wallet, you could just completely abstract away this whole flow from the user and just generate one for them as soon as they connect to the website and just start signing stuff under the hood. Whereas this, it will sign stuff under the hood, but you still need some level of knowledge about, okay, my email is being associated with a wallet. And maybe you want the user to know, hey, we're creating these wallets for you. Maybe there's some legal aspects involved with that. I'm not entirely sure, but I'm saying it's harder to use with a higher level of security than the other two options we've run through so far. The next one on this list is something we all know and love as Web3 developers, is the browser wallets. So this is the stuff like MetaMask, the stuff like Coinbase Wallet, Wallet Connect, all of the browser extensions or mobile applications if you're in a mobile environment that are going to enable you to connect your wallet that is inside of the browser extension or inside of the application to the application or game, whatever it is you're wanting to connect to. So we're gonna put browser wallets here, and just in brackets is gonna be MetaMask, Coinbase Wallet, and Wallet Connect. And in our little demo application here, you can see I'm in a state as I would be a kind of new user. I've never installed any of these browser extensions before. So if I click Connect Wallet, this is kind of intimidating for me. I don't know what MetaMask is. I don't know what Coinbase Wallet is. I don't know what Wallet Connect is, right? And especially if you're new to the Web3 world, a lot of these words will have negative connotations. So you can see if I click MetaMask, it's going to say scan this QR code with the camera or MetaMask. I don't know what that is, right? What about Coinbase Wallet? Again, I'm going to scan a QR code. I don't really want to do that. I'm kind of skeptical of scanning random QR codes that it suggests for me. If I click Wallet Connect, it's going to be the same thing. It's going to take a little longer to load. And here it is. So you can use this QR code again to log into the application from your mobile device. But, you know, there is some nice stuff with the Web React SDK where it gives you an explanation of what this stuff means. You can download the Chrome extension, et cetera, et cetera. But again, for new users specifically, this is very intimidating, right? And if this is the first thing your users see, I think you're going to lose a lot of users right off the bat. If this is what people see that aren't familiar with Web3 and you're expecting them to perform this operation every time they want to write data to your application, which is sending it to the blockchain, I think this is unreasonable depending on what audience you're serving. So this is an important note. I think a lot of the applications that get made today in the Web3 space are serving people in Web3, right? The audience is people that are familiar and people that want the benefits that the blockchain enables inside of the application. So they know what a MetaMask wallet is. They know what these browser extensions are. So it really depends. Is your app going to the kind of masses and trying to onboard people from Web 2 into Web 3? Or is your app, you know, it's an app that's basically going to a Web3 audience that already knows what the blockchain is, already knows what accounts are, and majority of them will already have some of these extensions installed. The next two wallets that we're going to talk about in this little chart here are really for experienced people in the Web3 space. They are going to be smart contract wallets that use an EOA or externally owned account wallet to act as the signer of that smart contract wallet. So this kind of requires an understanding of accounts, an understanding of smart contracts, understanding of how transactions flow in the kind of EVM world. And this is something that you can't really expect everyday users to be able to understand or have them as requirements to use your applications. So for these two, we're going to put them at very hard to use, but very strong security. And they're kind of similar, they're just implemented a little bit differently. So the first one I want to talk about is safe wallets. And this is formerly known as Gnosis Safe. So let's just say safe wallets. And this is what's known as a multi-sig. And multi-sig represents a multi-signature wallet. So you set up the account with multiple signers, which is what the SIG part stands for in multi-sig. Hopefully that's self-explanatory. There's multiple signers that are required for the execution of transactions from that safe wallet. So every time you go to make a transaction from the safe wallet, it's going to say, hey, you plus two other people or you plus one other person needs to approve this transaction in order for us to actually execute it. So this is suitable especially for business wallets, or maybe a family wallet, or a wallet between partners creating an NFT project or something like that. This is more suitable where you say, I really care about the security of this and I want some methods of recovery, because what if I lose access to one account, or what if somebody else in my business loses access to their account? The wallet is still able to execute those transactions and update who has access on the safe wallet to actually perform operations and perform updates on the blockchain, right? So this is very secure, but again, this requires huge kind of learning curve into what it means to have an EOA wallet, what it means to have a smart contract wallet, and how transactions execute. So if we go to our demo here, you can see first, it's going to ask you to link a personal wallet. So this is going to be one of the signers in that multi-sig. So let's say I set up one with my MetaMask and my friends set up one with their MetaMask or one of the other wallets. You can actually use the local wallet here if you really wanted to. Any of the wallets that have permission to execute those transactions in the smart contract wallet can sign in here. So let's say I signed up with my MetaMask wallet the next step is it's going to say, what's the smart contract address of that safe wallet? So you'll connect your personal wallet. That is one of the SIGs in the multi-sig. Then that is going to be able to initialize transactions from the multi-sig wallet. The setup really depends. Do you have a requirement for more than one person to approve transactions in order for them to go through? The rules are really up to you in this situation. So that is what that looks like. The next one I wanted to show you is very similar. Again, it is just a smart contract wallet. So let's put this in kind of the same boat. I'm just going to copy and paste this little guy over here. So I would say they have the same difficulty to use them, but they are similar levels of security. I would say they're somewhat more secure just because you can really control anything that's going on. And again, if you really want to know more about account abstraction, I do have another video on my channel that will be linked in the description. So we're going to talk about just pure smart wallets with, instead of the generated EOA wallet here, with a wallet that you control. So let's just say smart wallets, right? So instead of generating the signer for this wallet, the user has their own wallet. They bring their own wallet, such as a browser wallet, and that is the signer that they're connecting with first. Then we generate the smart contract wallet associated with the wallet that they control. So you can see here, first you would link your personal wallet, and then the next step would be, okay, for that personal wallet, we're going to use that wallet signer as the signer for the smart contract wallet. And this smart contract wallet can really have any functionality that you want, including multi-sig, including recovery mechanisms. And I do, again, have another video on EIP 4337 account abstraction, which I believe is what we're going to be seeing more and more of in kind of interacting with applications in the future. So for me, this is kind of the final chart, and I would say I've covered a broad range of different options. If I missed anything, please let me know in the comments below. If you enjoyed this kind of content, please hit the like button so it reaches more people like yourself in the algorithm. Appreciate it very much. And subscribe to the channel if you haven't already. Appreciate you watching, and I'll see you in the next one.